Hello and welcome to section 2.4. Here are the solutions for 2.3. And if this question here was a little tricky for you, showing that if you take two integers that they're even, their sum also has to be even. I can go over that with you guys in class. A little tricky question. We're going to use postulates and diagrams today, working with points, lines, and planes. Basically going back to chapter 1, we're going to be seeing a lot of things that you guys saw in chapter 1, a lot of rules that you guys learned in chapter 1, we're going to formulate them into postulates today. So postulates and axioms are rules that are accepted without proof. We're going to be proving a lot of things this year. They're called theorems. We get to use these without actually proving them. So you're going to want to jot these down in your notes. There's a lot of them, and we're going to be referencing them a lot. I don't memorize these. It's just too much work to memorize these. So if you forget which postulate is which, that's okay. You just need to know the concepts. For example, through any 2 points, there exists exactly, well, if I have 2 points here, okay, there's exactly one line that goes through those 2 points. Okay, a line contains at least 2 points. If 2 lines intersect, then their intersection is exactly 1 point. So here's 2 lines, and they intersect in 1 point. Okay, the next one is through any 3 non-collinear points, there exists exactly 1 plane. And we talked about this in class or in chapter 1. If the 3 points are collinear, there's an infinite number of planes that will go through there. So 3 non-collinear points, that's the key word right there, non-collinear. A plane contains at least 3 points, kind of like almost like the converse or the opposite or the switch around there. And then, let's see, if 2 points lie in a plane, and the line containing them lies in the plane. So here's our plane. Here's my 2 points right here, okay? So if those 2 points are in that plane, then this line also has to be in that plane. So that's what that one. And a lot of these are really, seem really simple or really straightforward. If 2 planes intersect, then their intersection is a line. So this is the example with the wall. So if you look at how 2 walls will intersect, their intersection is that line that they share. So I'm not going to draw that one because my diagram will look awful, but I can show you guys a picture of what that looks like. That would be right here. So this is postulate number 9 right here. If 2 planes intersect, then their intersection is a line. And this one here, this first one, if 2 lines intersect, then they intersect at 1 point. That would be postulate number 7. Okay, so this one's postulate number 7. And like I said, as you notice, I have to go back and look at my notes, just because I'm not going to memorize all of these. You just have to know what this is saying. So this one, letter A says if 2 lines intersect, then their intersection is a point. Letter B says if 2 planes intersect, then their intersection is a line. This slide back here said algebra connections. How do we graph lines? Well, when we graph lines back in algebra, we would start with like the y-intercept, and then we'd apply the slope. We'd go up and then over, and we'd plot a new point. Once you have 2 points, you could draw the line. You needed 2 points to create the line. And so that one is right here. Through any 2 points, there exists exactly 1 line. And then systems. How do we find the solution to a system of linear equations? That's where we would graph the two different lines, and then we'd figure out where they would cross that. That solution set, or that solution to the system was a point. If we look back at our postulates here, if 2 lines intersect, then their intersection is exactly 1 point. We were finding that point where they crossed at. So there's some algebra connections to this. Use a diagram to write examples of postulate number 9 and 10. Okay, so let's go back and read number 9. Number 9 says a plane contains at least 3 non-collinear points. We got to find 3 non-collinear points here. We could say, let's see, C, B, and A. So plane P contains points A, B, and C. And there you go. And then postulate number 10 says if 2 points lie in a plane, then the line containing them lies in the plane. Oh, by the way, positives 1, 2, 3, and 4. We did not talk about this one. You don't need to write that down. We did talk about segment addition, and we did not talk about number 3. So if you're wondering why we started at number 6, that's why. We actually talked about 2 and 4 in this class. So number 10 says, if 2 points lie in a plane, then the line containing them lies in the plane. Okay, so we got to find the line in a plane. So let's see. A and B lie in plane P. Line AB also lies in plane P. So there you go. That's postulate number 10. This is interpreting diagrams. Is very important on what you can assume and what you can't assume. So this is a skill that you're going to have to develop over the course of this year. So we're going to practice this right now. I'm just going to go through each one of these statements. We're going to analyze them. Actually, we'll do this as a class. We're going to do this as a class. This is a fun activity. So we're going to do that as a class. Otherwise, it might not make a lot of sense doing it in the video. So skip that for the time being. I'm going to draw a picture for you guys. A lot of geometry is drawing pictures if you haven't realized. So learn how to sketch things. Sketch a diagram showing TV intersecting at PQ at point W so that TW is congruent to VW. So PQ is a segment, and we know that it's a segment because it has no arrows above it. And then TV is a line intersecting PQ. It doesn't say anything where, so I can just draw it wherever. Okay, so here's my line, here's point W right there. That's where they cross at. TW has to equal VW. So T and V, TW is congruent to VW. Okay, so T and V have to be on there so that they're equal. So I want to make them approximately the same. So here's TW and here's VW, and they are congruent. We're going to put those marks there. Those marks mean that they are congruent. So it doesn't say anything about PQ, we just know it's a segment, and that's all. And then perpendicular lines to planes. So line is a line perpendicular to the plane if and only if the line intersects the plane at a point, and is perpendicular to every line in the plane that intersects at that point. This definition is a mouthful. So in order for T, so T is perpendicular to plane A. This is plane A. You can tell by the capital letter there, plane A. Because T is perpendicular to P and T is perpendicular to Q. So T has to be perpendicular to every single line that it intersects at that plane. And then you can say T is perpendicular to the plane. Just a really complex definition. I can talk about that more in class as well, because that definition is rather extensive, as you can tell there. Let's see, which of the following can be assumed or cannot be assumed? Let's see, this one, A, B, and I'm actually going to go over this one as a class too. Some of these diagram pictures are just better to go over as a class, so we'll talk about them and we'll get some class participation there at the beginning of the hour tomorrow. And then that's the assignment. So expect to go over some examples tomorrow. It'll make a little bit more sense with interpreting diagrams. Normally the class discussion is pretty good, and you'll learn a few things on what you can and cannot assume. Thank you guys for tuning in to 2.4.